This is Mary Tobin at OpenWorld 2011. I'm here with Amir Halfon, who is Senior Director of Technology for Oracle Financial Services. Amir, this week you're speaking to the group on avoiding the next financial crisis, getting a grip on big data in capital markets. Can you tell us why it is important for financial institutions today to really get a better and more accurate picture of risk across their assets and classes and lines of business?
So I think this is probably one of the biggest lessons learned from the crisis of 2008. One of the big aha moments was when Lehman went under and all the financial firms were having an extremely hard time understanding their exposure to Lehman across all the different asset classes. And it was one of the causes for this big systemic risk, the fact that it was very hard to undo all of the interactions and interconnections between all the different entities across different asset classes and different OTC derivative contracts and so on. So the regulators, after the crisis, really focused on that systemic risk as a big focal point, and therefore they're now requiring, as part of regulations like Dodd-Frank, etc., to get that sort of aggregated view of risk exposure from the member firms. So this is a challenge across the industry, but also for each firm individually to just get that sense of the aggregated exposure across all those different lines of business, different geographies, different asset classes, different instruments, etc.
Very good. And what role does the ability to manage large amounts of structured and unstructured data play in achieving this enterprise-wide visibility?
So this is obviously all about data, right? You get the risk exposure from positions data and from the actual data about the instruments, the reference data, the data about the entities, how they relate to each other, how, let's say, a single entity like AMBAC, for instance, can be a guarantor of one instrument, but also an underwriter for another and an issuer for a third. That's essentially the key aspect here, is how do we get all the data and how do we get the relevant data out of the huge amounts of data that is out there, and the data that is not necessarily structured in the way that we can consume it in the right fashion. So for instance, you're asking about unstructured data. A lot of those OTC derivatives that were sort of, again, at the heart of the 2008 crisis, at least, were not necessarily stored in a way that's structured. They're just contracts, and you need to extract the entities out of them to get at the data that you need. And this is why we're actually saying that this is a sort of a big data problem. I may be preempting your next question, but part of what defines big data is this variety of different kinds of data, loosely structured, unstructured, structured, and coming from a whole bunch of different places at a very fast pace, and also having a relatively low density of information. So you get vast amounts of data. We're looking at market data, for instance, growing exponentially through the years. So every year you're seeing more and more data coming at us at the system. And yet the data that you're interested in is sort of buried within it somewhere. So that's one of the key challenges. So this is all about enterprise data management, essentially.
Excellent. And how is Oracle helping organizations in terms of managing and really capitalizing on their big data?
So I mentioned two aspects already of big data, which is velocity and variety, and I guess also the notion of value, right, with low information density. Those are three of the big V's, with the full one being volume, obviously, which is the most important one, and hence the name big data. So maybe start with that one. I think what we're seeing there is customers moving away from moving data around towards moving the compute tasks, the risk analytics, all of those calculations closer and closer to where the data lives. So moving the compute to the data is a big sort of design pattern, overarching sort of technology pattern. And what we're doing at Oracle is sort of implementing that in several different ways across many different technologies that are all integrated to work together. One of them, as I'm sure you've been hearing a lot at OpenWorld, is engineered systems. So with engineered systems, we can, because we control everything from the software all the way down to the lowest levels of the hardware and the networking in between, we can actually move some of the computation tasks very, very close to the data. So Exadata is a great example. We'll take the query execution and we'll move the where clause execution right to the storage nodes where the data is located. We're doing the same things now with things like Exalytics and Exalogic, and pretty soon the big data accelerator that all of which was announced this week. Again, the notion is to take away that sort of choke point of the data moving across a very thin pipe across the network. So this is one aspect. Another one is, and that was also announced this week, moving away from only doing things in a relational database. And this is by no means saying that relational databases are insufficient, but they're extremely well suited for deep analytics. But here we're talking about other types of problems which have traditionally been solved using different technologies. So one technology we announced is NoSQL, the NoSQL database, which is a distributed key value store. Again, it allows you to do things in memory in a much faster way to get much better access to a distributed file system, etc., etc. Similarly, a technology we've had for quite a while and that we're seeing a lot of customers use very successfully to solve these kinds of problems. For instance, to aggregate positions across the firm, right, across different geographies, is called coherence. And this is a data grid that allows you to hold vast amounts of data in a massively scaled data grid, again, with the data actually held in memory and with the compute tasks executing right at the node where the data is held. So these are just a few examples. We can talk a little bit more also about some other technologies that are coming up that will perform analytics, again, very, very close to the data. I'm talking specifically about another announcement that was just made, which is the availability of Oracle R Enterprise. R, as you might know, is a very widely used statistical analysis package that is quite common within financial services. People may be familiar with QuantLib that's associated with it. And we have just announced our own implementation of R, which takes it out of the realm of the laptop used by the analysts to the realm of massive, data sitting right on the operational data store. So we've taken R, we've parallelized it, we made it multi-threaded, and we made it execute right on the database nodes, and again made it execute much closer to the data while still allowing the analysts to retain their consoles and their familiar sort of interfaces.